This is a map of internet addresses circa 2006 from the comic XKCD. And this way of drawing the internet as a map has become very popular because it does it in a clever way. Instead of just counting 0 to 255 across in rows, say, which would mean that you have some wraparound effect when things are close together but happen to be on the border, end up being far apart. This drawing instead uses a Hilbert curve, which goes back and forth and squares around like this, and ends up keeping things that are close together numerically also close together geometrically. What you see in this map are the names of some companies that reside at those positions. In particular, 17 here is labeled Apple, which is consistent with that mail address we look up. Some areas are special, like the multicast area here. These numbers are not mapped to specific hosts, but are used for special routing possibilities. The green areas here, some of these are reserved, but in 2006, all of these green areas were unallocated parts of the space. You see certain regions tend to be close in number and also close geographically, like USA, Canada, and Europe, and then a lot of things marked various registrars. This was 2006. By just a few years later, in 2010, things had changed quite a bit. This is a map produced by someone else. It's from ISI at USC. In this map, the blue regions are unallocated things, and you can see there are many few of them. There are this other teal shade that are the special purpose things that are still there, but not nearly as much blue that would be mapped to green as before. So that reflects the growth of the internet that happened in 2006 to 2010. And for a much more recent picture, we basically see no unallocated area at all, but also the labels have changed. The labels have gone from being geographic regions to these things like ARN, AP, and IC, and so on. These are all names of different allocation agencies, and you can go to a web page, iana.org, and it shows you how these different names map to different regions of the world. But the distribution of management got reorganized into these agencies in the past 15 or 20 years. One thing I think is interesting, if you go to the RIPE, RIPE NCC page, and go to IPv4 waiting list, then it'll show you that a bunch of people are waiting to try to get new numbers, and they've been waiting for about 500 days so far. So it's much harder to get numbers than it used to be. You can find estimates on the web, and one recent estimate was about $50 is the cost of one IP address. You can't really buy one IP address at a time. You buy them in blocks of 256 or larger. But it reflects, again, how these addresses have become rare, and it also means that companies that got big blocks early on, like AT&T and Apple, they're sitting on a pile of addresses worth a little bit less than $1 billion. If you want to dig in more into who controls different addresses, they're organized into autonomous systems. So AS is the abbreviation for that. The University of Utah is Autonomous System 17055, and it has control over these subnets. So we see the 155.98 subnet here. All 65,000 of those addresses are managed by the university, and also some other nearby numbers. You can see that it's not as tidy as you might like a simple range that's all the University of Utah, because different chunks of the address space were picked up by different parts of the university at different times and have gradually been reorganized. I'm not entirely sure why there are numbers like 198.32/20, that prefix is contained inside of the 155.98.16, but there are probably some organizational details that are different between this subnet than the 155.98 subnet. If you're interested in other things, you can go to ipinfo.io and look up other autonomous systems. Besides these IPv4 addresses, though, that page will also show you IPv6 blocks. And the University of Utah's space in IPv6 is nice and tidy. It's 2604C340/32. IPv6 addresses are 128 bits. So having this 32-bit prefix means, well, I don't even know how to read this number, but many, many, many addresses, so many that we will definitely not run out. So that's the big switch, and going from IPv4 to IPv6. We will talk more about that switch a little later on, but it's easy to motivate at this point why you would want to do that, because for many purposes we have run out of addresses.